Hi guys, today we'll be creating this simple dungeon layout generator. And with this you can generate dungeons similar to those found in Soul Knight or the Binding of Isaac. I'll be making this project in Godot, but you'll be able to do this in any game engine. The general idea will stay the same. So I'll just start a new project. The first thing we're going to want to do as soon as this loads is create a new scene, and our dungeons are going to be composed of rooms, so we're going to first want to define what a room is. We're not actually going to be generating what's inside of the dungeons, just the general layout. So for our purposes, our room is going to be very simple, but if you were to implement this in an actual game, you'd have to add doors and transitions between rooms. If you want, I could create a tutorial about that later, but today it's just dungeon generation. So we're going to name this room and add a script to it. And it can be named room.gd. And our room, we don't need a ready function, we just need a dictionary that holds the room. Here, I'll write it out first. So this dictionary called connected rooms, it stores, it has 4 items stored in it, and each of them is a vector in a certain direction, and each of them points to an object. So a dictionary is basically a hash map if you've ever coded in Java or C++, or if you have but you don't know what they are, hash map is basically, it's like an array, except instead of 0, 1, 2, 3, and 4 leading to whatever you're trying to find, it uses other objects to point, it uses other objects as keys to point to the object you're trying to find. In addition to this, we'll also create another variable called number of connections, and this will basically store how many connections this room has to other rooms. You don't really need this variable. You could actually just create a function counting the number of these that don't equal null, but I find this more convenient for what we're going to use it for later. So that's all that needs to be done in room for our project, and we're gonna now move on to the actual dungeon generation. So our dungeon generation script is not going to be a scene like the room, it's actually going to be a standalone script. So we can just name it dungeon generation. And in order for this script to be able to be called by other scenes, we're going to have to add it to the auto load path. So just select the script in project settings, and then go from general to auto load and just load the script over here, and you can just name it dungeon generation and make sure that singleton is enabled. And in this script, the first thing we're going to want to define is how large we want our dungeon to be. So for maximum randomness, we can define a min number of rooms and set this to 6 for now, and then we can also set a max number of rooms. And this can be 10. And every time we generate a dungeon, we'll just select a number between the min and the max, so not all dungeons are the same size. And aside from that, we're also going to want to be able to use our room scene in our dungeon generation script. So to do that in Godot, we just do var a room equals preload and then just the path to the room scene. So for me, that's res room.tscn. Alright, the next variable we're going to want to define is the room generation chance. And this is basically the chance that a room will spawn, that a room will branch off of the current room we're trying to spawn it off of. This will make more sense as I get more into how our dungeon generation algorithm actually works. But for now, just know that the higher this number is, the more likely that a room will spawn, but also with that, I feel the less interesting our actual dungeon layout becomes. So I'll just set it to 20 to start, which means 20%. Well, we don't need a ready function, but we do need our generation function, which will return a dungeon. And in our generate function, we're gonna actually want to accept a number as an input, which will be the room seed, so that we, in case you want to generate a random dungeon, the same random dungeon for testing purposes, you could use the same seed. So to actually apply the seed to this random generation, we do seed, room seed. Alright, our dungeon is actually also going to be a dictionary. It's going to store where each room is and the actual room object itself. So it's just like our connected rooms dictionary, it'll be a vector to an object, but it'll start out empty. That's all we need out, and we also need to determine for this dungeon how large it's going to be. So to do that, we just do size equals rand range, and this will return a float between a min number of rooms and max number of rooms. But we actually want it to be an integer, so we can solve that by just flooring the number that it returns. So let's say it returned 3.5, it would return 3. And to start our dungeon off, we're actually going to want to create a room in the center, and that's where all the other rooms are going to branch off of. This will ensure that all the rooms in our dungeon are connected and that there's no like islands of rooms that can't be reached. So this just selects the key in the dungeon where the vector is 0, 0, and we can set that to room.instance, a new instance of our room scene, which is over here. It just has these things stored. And since we added a new room to our dungeon, we're going to actually want to decrease the size by 1 because a room has been added. And now here's where the actual generation comes along. So here's a visualization of what's actually occurring in our script. In the beginning, a random dungeon size is generated, in this case 8 for this dungeon. And over here you'll see the generated number between 1 and 100, and if it's less than the room chance, then a new room will be created in this randomly generated direction. So if we click generate, you see 77 isn't less than 50, which is our which for this script is our generation chance. So 77's not less than 50, so a direction wasn't generated. And it keeps going until it generates a number that is less than 50, in which case a direction is generated and you see a new room in this direction was created, and the rooms left was decreased by 1. And it keeps going. It cycles through all existing rooms, so you see before it was over here, now it's over here, and it has generated a number less than 50, and in the same direction it will generate a room. This number is randomly generated, and it keeps going until rooms left is equal to 0. And let's keep going until this dungeon is done. Now you can see rooms left is equal to 0, so at this point our dungeon function would just return this dungeon as a whole and it'd be done. To give another example, here's another dungeon, and as you can see it's branching off if this number is less than our generation chance. And it keeps going. Oh, in this case, you see our dungeon generation algorithm was on this room, and the number it generated was less than 50, but the direction it chose was downwards, and a room already existed in that position. So what our algorithm does in this case is it just creates a new path between these two rooms. And this dungeon is now done. So that's basically what our algorithm will do. And here we'll start with the actual generation. So we're going to want to create a while loop while size is greater than 0, which means that there are still rooms left to be generated. And while the size is greater than 50, we're going to want to loop through all of the rooms in the dungeon. So to do that, we'll just do for I in dungeon dot keys. And then for all of the rooms in the dungeon, we want to see if a room should split off at that point, and that's determined by if the rand range 0 to 100 is less than our generation chance, which basically gives us a 20% generation, or a 20% chance that a room will generate from this room. And now we're going to want to select a direction if a room were to be created, in which direction it were to be created in. So create a new variable and just name it direction, and it will be a number between 1 and 4, or 0 and 4. And then now I'll add a bunch of if statements checking the direction in which the room is. Alright, so to create a room, all we have to do is we know where the room we are on is. That's I, so I is the room we're currently on, and in direction 1 the room that's generated will be in position I plus a vector, so plus a certain vector. So in this case we're going to do vector 1, 0, which is to the right. And what we want to do is we want to check that if a room already exists in the dungeon at that position, because if it does, we don't want to overwrite it. So in order to do that, we can just do if dungeon.has, and if it has, or if it doesn't have, to check if it doesn't have, we just add an exclamation point in the beginning of this. So if it doesn't have it, then we just create a new room in that position. We do it the same way we did it over here. So we just copy and paste that here, except instead of vector 0, 0, we do it in the new room position. and that just creates a new room at that position. And now we want to connect the two rooms, and the two rooms will be connected based on what's inside of this connected rooms dictionary inside of each room. So let's say there is a room defined here. That means that this room is connected to the left of that room. So what we want to do here is I'll actually create a new function called connect rooms. And we're going to want to accept a room or two rooms and a direction. The direction is going to be the direction of room 2 relative to room 1. So what we've done here is we've and over here, if you remember, we have the number of connections variable. We're just gonna want to increase that by 1 for both of the rooms. And once we get back here, we're just gonna want to connect rooms, get the room at position I, and then get the new room at the new position. And a vector. Alright. We're also going to want to decrease size by 1 after we create a new room so that this loop doesn't run forever. So we just do size minus equals 1 over here. And we don't put this in the if statement because this only runs if a room doesn't exist in that position. But if a room does exist in that position, we don't want to create a new room, but we still want to connect the rooms. Create a path between the new two rooms. And all we have to do now is to just copy and paste this into into the rest of these. You could create a new function with just these contents, but I don't think it's that necessary. And for the rest of these, make sure to change the vector2 values. And after all this, all we have to do is return dungeon, and it should give us a generated dungeon. In order to test if this dungeon works, we're going to actually create a new scene and this will show us where the dungeon is, or show us the contents of our dungeon dictionary. And I'll just provide the code to this probably in the description. This isn't very relevant to what we're actually, or this isn't relevant to the actual dungeon generation, so I'll just give you the code. And then inside of this scene, in order to view what's going on, we're going to want to add a camera 2D. And we can scale it down to 0.3, 0.3. And we'll also add a button to generate new dungeons without having to open and close the program every single time. And in order to connect this button to the code, just go over here from inspector to node, click pressed, and then click connect. And make sure dungeon tester is highlighted and click connect. And we're also going to want to add a new node, name it map node, and this is inside of this is where all the testing sprites will be drawn. Oh, speaking of that, in order for us to actually see what's going on in the dungeon, I'll provide some assets to actually draw the dungeon out. They're the ones you saw in the beginning of the video. Import them like this. And then you want to disable the filter. Select both of them, go from scene to import, and then make sure that filter is unchecked. And that'll make sure that the pixel art is clear, because otherwise it would be blurred like this, and we don't want that. Now if we run our program, we should see, oh, I forgot to, you have to click on camera, make sure that current is selected. And now when we run it, you should see our dungeon. Every time you click generate, a new one should be present. And so our dungeon generation algorithm is pretty good, but sometimes it generates dungeons such as these, which aren't that interesting and probably wouldn't be that fun to actually play in a real game, because it's quite linear, unlike how you'd want a dungeon to be, which is mostly about exploration. And in this case, the only options you have is to go straight up or up and to the left. And to solve this, there's actually a real simple way to solve this. Go over here. You just have to create a new function, and it's going to be and it's gonna just call it is interesting, and it'll accept a dungeon as input. Yeah, so to define a dungeon as interesting, I feel that a dungeon is interesting when there are at least 2 rooms, or when there are at least 2 rooms with at least 3 connections. So like over here, this room is connected to that one, and that one, and this room's connected to over here, and here. So this one would qualify as interesting with 2 rooms with at least 3 connections. Over here, this room wouldn't qualify because it only has 1 room with 3 connections. This one would qualify, I think. No, I lied. This one wouldn't qualify because there's only this one with 3 connections, and the rest of these only have 2. And this one has 2, and that one only has 1. So that one wouldn't be interesting. So in order to count the number of dungeons with 3 connections, we'll create a variable that stores how many dungeons with 3 connections, or how many rooms with 3 connections we found so far. So just name it rooms with 3 and set it to 0 to start. And then we're gonna want to loop through all of the rooms in the dungeon. So like we did before, we're gonna want to go through all of the dungeon keys, and then if get I, and so this gets the room that's associated with the key position. And if you remember, in our room we have the variable number of connections, and this is where it's put into play. And if we just check if the number of connections is greater than or equal to 3, and if it is, then rooms with 3, we add 1 to it. And then now after it's looped through all the rooms, we're just going to want to return if rooms with 3 is greater than or equal to 2. And then now, actually, we have to actually add it to our generation code. So while the dungeon isn't interesting, we're going to want to replace it with a new dungeon, but with a different seed, because if we use the same seed, then it would just keep on generating the same dungeon. So to do that, I like to do room seed times rand range. And that'll just give us a new dungeon. Alright, with this, dungeons generated should... Alright, I found out what was wrong. So in our connect room code, we're increasing the number of connections by 1, but we're not checking if a connection already exists in that direction. So that means if the room were to try to create a connection in the same direction as one that already exists, it would be the same exact connection, except number of connections would still increase by 1, which we don't want. So it's a simple fix. We just do if dungeon dot okay new room position dot and then just connected rooms. We're accessing this dictionary, and then in this dictionary we want to get this vector position. And we want to check if it's equal to null, which means that if a connection doesn't already exist in that direction. And if it doesn't, then we run the connect room code. And remember to replace all the numbers in here with the same vector that you used over here and here. So -1, 0, 1, and 0, -1. Some of you may have seen it already, but I don't know what I did. I said null, but I typed 1. I don't know why I typed 1 here. You're going to want to replace all these ones with null. And now if we run it, we should only get the interesting dungeons. Interesting. Yep, interesting. Yep. The fuck? What happened here? I found the problem. Instead of new room position here, we're actually going to want to do I in the checking if a room exists over there. My bad. This is because we're going to want to check from the original room relative to the original room instead of the room we just created. And now, finally, should work. That's good. That is good. That's good. Right, so we're basically done, but If you want simpler dungeons, or you could just decrease this number to, let's say, 5 and 8. I probably wouldn't go below 5. Oh yeah, here's an error that you might run into with your program. And this occurs due to the Stack Overflow, because maybe there's too many variables being created. Let's see, 51. Yeah, at this generate. So we're creating a new room instance with every run of these, but every time we replace the dungeon, we're actually not destroying them. So to actually destroy them and free up some space, we're gonna want to loop through all the dungeon rooms again. And we're just gonna want to destroy them. And in Godot we just use queue_free. And now I lied. For min number of rooms, you want to keep it at 6, because if it's at 5, it's actually impossible for it to have 2 rooms with 3 connections. So if you were to want to have just a dungeon with 5, then I wouldn't use this check over here. Either that, or I would decrease this number to 1, or maybe just check for numbers with 2 connections. But yeah, this part over here is still necessary, but if you're going to use the same isInteresting function as me, then don't go below 6 rooms. But even with this, the dungeons that it creates, still pretty cool. Alright, and that pretty much wraps up my dungeon tutorial. Let me know if you want to know how to actually create the rooms, or if you want any more tutorials. This is my first video on the channel, so I'm really not sure what I'm gonna do from here. And yeah, thanks for watching. Maybe consider giving a like or subscribe to follow the channel if you liked the video. And thanks.